Find the exact coordinates of the centroid for the region created by y is equal to the square root of x, where our x values goes from 0 to 4. So first step for these problems is when you're given a function and you're looking for center of mass or centroids, is to just always sketch. So if we sketch our graph, we will receive a curve that starts at 0 and looks like this. And what this actually is, it's the upper half of the parabola, or y is equal to x squared. But since it's only defined in y is equal to the square root of x, so it has to be positive only. And if we draw our bounds going from 0 to 4, we can see that our problem is asking us to find the point on this little area. Let me shade it in green. Our problem is asking, where is the center of this little shape that we created with our bounds and the area under our curve? So this point, our centroid, we can call it x bar, y bar. And these are equal to our centroid. So both of these x bars and y bars have their own little expression. So if we do x bar is going to be equal to 1 over a, and we'll get to what a is later. 1 over a of our integral going from a to b of x times our function f of x. So let's put that in parentheses, and then our dx. And y bar is equal to 1 over a times the integral going from a to b of 1/2 times our function squared. So just our function is squared there, dx. And then our a is just the area of our function. So we'll just have a is equal from the integral going from a to b of f of x dx. All right, so now that we know what we're looking for, we can just plug and play. So now we can start looking for the area. That's always going to be helpful since we need it to solve for our x bar and our y bar. So we'll have our integral going from 0 to 4 of square root x dx. When we take this integral using the power rule for integration, we'll have x to the 1/2 plus 1 all over 1/2 plus 1. So that'll be x to the 3/2 all over 3/2. And just getting rid of the fraction in the denominator, we move this 2 up to the numerator. So we'll have 2/3 x to the 3/2. So if we evaluate this going from 0 to 4, we'll have 2/3 times x, which will just go from 4, and that is to the 3/2 power. Okay, now if we just write 2/3, we can interpret this 4 to the 3/2 power as 4 times square root 4. And from here, square root of 4 is equal to 2. And then 2 times 4 is equal to 8. So we'll have 2/3 times 8, which just reduces to 16/3. And that is equal to our area. So here, let's make a note, equal to 16/3. Okay, let's make some room. Let's just go with x bar since that's the first one that comes up in order. So step 3 now, we're at x bar is equal to 1 over a, which is just 16/3. So 1 over 16/3. And our integral goes from 0 to 4 of x times the square root of x dx. So the same manner, get rid of this fraction in the denominator. We'll take that 3, move it up to the top. So we'll have 3 over 16 of our integral going from 0 to 4. X times x to the 1/2. Using our exponent rules, we'll have x to the 3/2. Since 1 plus 1/2 is 3/2. So x to the 3/2 power dx. We leave our constant on the outside. And if we just perform our power rule for integration for x to the 3 halves, we'll have x to the 5 halves power. And then here we'll have 2 on the numerator, 5 on the denominator. And then we'll have 2 on the numerator, 5 in the denominator. And of course, this goes from 0 to 4. So when we evaluate this, we'll have 3/16 times 2 over 5. And still in the numerator, we'll have 4 to the 5 halves power. Using our calculator, we'll have 3/16 is equal to 64/5. And then by reducing that, we'll have 12/5 is equal to our x bar. And we'll make a note of that right here. So if this is x bar, y bar, like that, this right here will be 12/5. And then let's find our y bar. Okay, so step 4, our y bar. So that will be equal to our 1 over 16/3, which is just 3 over 16. Going from 0 to 4 of 1/2 of our function's square root of x squared dx. So the square root of x and x squared, those are inverse operations of each other. So that will just cancel out. That'll just become x. And then 2 times 16 is 32. So we'll have 3 over 32 on the outside, because we're taking that 1/2 constant to the outside of our integral, going from 0 to 4 of x dx. And then same way with our power rule, we'll have 3 over 32 of x squared over 2, going from 0 to 4. And then just by simplifying this, we'll have 16/2. And then that just reduces to 3 over 32 times 8. And that will be 3/4. So now, what we've concluded with all our calculus is that this point right here is going to be equal to 12/5, 3/4. And that's our centroid.